myself Viren Patel, associated with LJ Institute of Engineering and Technology. So, in this chapter of superconductivity, we have discussed properties of superconductor, Misner effect, BCS theory. It is also known as mechanism of superconductivity, and also we have discussed the types of superconductor and penetration depth. Now, in this video, we are going to discuss the applications of superconductor. The topics are Josephson effect, Josephson junction, Squid, magnetic levitation, and Cryotron. So, let's start with Josephson effect. So, it is discovered in 1962 by Brian Josephson. So, what is Josephson effect? So, it is the flow of electric current between two superconductors separated by thin insulating layer. So, here in Josephson effect, two superconductors are separated by a thin insulating layer. Now, let's see what is a Josephson junction. So, a Josephson junction is made by sandwiching a thin layer of non-superconducting material between the two layers of a superconducting material. So, you can see in the figure that here two superconductors are S1 and S2. There is an insulating layer between these two superconductors. So, as you can see in the figure that Josephson effect is the current flowing through that two superconductors S1 and S2, which is separated by an insulating layer. Now, you can see in the figure that there are two superconductors and there is an insulating gap. Here we know that in superconductor, upper pair is responsible for the flow of current. We have discussed that BCS theory. So that upper pair is nothing but the pair of two electrons which have opposite spin. Now, let's discuss DC Josephson effect. So, if a constant current is made to flow through a Josephson junction, no voltage drop occurs as long as the current is below its critical value. This is known as DC Josephson effect. Now, let's discuss AC Josephson effect. So, here, if a small potential difference is applied to a junction, then a small oscillating current starts flowing through the junction with a frequency F is equals to 2eV by H, where EV stands for electron volt. That is nothing but the energy absorbed or released by the electrons at a potential difference 1 volt. So, this effect is known as AC Josephson effect. Now, let's discuss the application of that Josephson junction, and that is Squid. So, Squid stands for superconducting quantum interference device, and it is invented in the year 1964. So, let's discuss what is Squid. So, it is a very sensitive magnetometer used to measure extremely small magnetic fields based on superconducting loops that contain Josephson junction. So, it is made of two Josephson junctions connected in parallel. You can see in the figure, there are two Josephson junctions which are in parallel. So, when applied magnetic field changes, there is a phase change at the junction, and this leads to the alternating current. So here you can see in the figure, when current flowing through that two junction, it flows through the two junctions parallelly. So when a magnetic field is progressively applied to that squid, the voltage of squid is periodic. And if this variation is measured, small changes in magnetic field can be determined. We can determine changes as small as 10 raised to minus 80 Tesla. So the application of squid is used to measure the Earth's magnetic field. Now let's discuss magnetic levitation, and that is used in maglev train. So first is, what is magnetic levitation? So it is a process by which an object is suspended over another object by no other support, but magnetic field is there. And how is it achieved? So because of Wisner effect, magnetic field lines are repelled and this produces levitation. We have discussed in Wisner effect that at particular temperature, or we can say that at critical temperature, superconductors behave as diamagnetism. So it repels the external magnetic field and it doesn't allow that external magnetic field to penetrate through it. So we can say that because of that effect, magnetic field lines are repelled and this produces levitation. So magnetic levitation is used in maglev train. So that maglev train moves without making any contact with the track or guide wheel. They use electromagnets and superconductivity to achieve levitation. They are efficient and environment friendly. Now let's discuss the two cases of that maglev suspension system. So let's start with that electromagnetic suspension. So electromagnetic suspension uses attractive forces to levitate the train. So here levitation magnets are attracted to electromagnets on guide wheels. Guidance magnets are used to guide the train. So we can say that here attractive force are used. So we can say that if levitation magnets has north pole, then the electromagnets on guide wheels has south pole. So by connecting that opposite magnets, we can achieve the attraction force, and this force is overcome the gravitational force. Now the second is electrodynamic suspension. So compared to electromagnetic suspension, here in case of electrodynamic suspension system, here repulsive forces are used to levitate the train. So you can see in the figure, here powerful superconducting magnets are used, but magnets of same polarity create repulsive forces between levitation magnets and guide wheels. Here we can achieve the repulsive forces by connecting the same polarity. It means that if the levitation magnets has north pole, so the magnets on guide wheels has also the north pole. It means that same polarity magnets creates their repulsive force, and if that repulsive force overcomes the gravitational force, then it easily levitates the train on the track. Now let's discuss the last application, that is Cryogen. So it is a switch that operates using superconductivity. It was invented by Ludwig Allenberg in 1956. It works on the principle that magnetic fields destroy superconductivity. So here, let's discuss how does a cryogen work. You can see in the figure, there is a central wire or port A and the coil is wound on it, and that is B. Here, the critical magnetic field of port is less than the critical magnetic field of that coil B. So what happens? The amount of current through the straight wire is controlled with the help of small current in core A. So now we know that if current flowing through the coil, then it generates magnetic field. And if that magnetic field or the critical magnetic field of that coil is higher than the critical magnetic field of that core, then it doesn't allow the current flowing through it. So here we can say that the amount of current through the straight wire is controlled with the help of small current in a coiled wire. So that's it for today's session. In this video, we have discussed the various applications of superconductor, that is Josephson effect and its application as a squid. And at last, we have discussed magnetic levitation and Cryogen. So, thanks for watching.